Assignment operators require L value, as we already specified earlier. The interesting part of the assignment operator implementation, and let's find an example of our assignment operator implementation right here in our string class. Operator equals like this. Actually, these are other operators. Let's find this. Okay, so this is a deep copy assignment example, and the move assignment is very similar to it, so we already know there is a distinction between the two, and this is how they appear overloaded in our in the declaration of our class string. It's almost always the case that the implementation begins to check whether this assignment operator, which is always implemented as a member function, checks whether its address is the same as another object, the prototype, right, the right-hand side of the assignment. And if that's the case, we just return this. So this is a way to return information from the assignment operator, and very likely that in your implementation, what assignment operator returns is a reference to an instance of your class. So these are just two highlights here. What we return from the assignment operator, and it's possible because we have this pointer, we can convert pointer to an object, and object then this dereference, this pointer becomes an object, and object can be perfectly well used to initialize a reference, and so we will return a reference from the assignment operator. So this is necessary for common type of chained assignments, such as A equals B equals C equals D. Okay, so this construct is called chain assignments, and because the association of the assignment operator is right to left, this will execute first, and the result of the assignment is going to be used in subsequent assignment, and then again in the next assignment. So this is why this chain assignment construct is possible, because of the associativity, right to left associativity of the assignment operator. And to be able to do something like this, we have to return a reference. So the result of this assignment becomes a reference basically to this object, because this operator member function is invoked for this object, right? So this is our object. So this is a pointer to our object, and this is a reference to another object. So this becomes another object right here, right? So this is like an object named D. So another is D, and this is C. So then, in order to be able to use C in the next assignment, we have to return a reference so that it can then be used like this. So then, in the next assignment, right here, B will be this, and C will be another. And so it will be chained like this all together through the entire sequence of these assignments. So just technicality, these little technicalities about the assignment operator. When we design objects such as string class here, Java-like string, which requires a management of the dynamic memory, and we have this pointer member that points to a block of characters allocated dynamically. So normally when you design a class like this, the concept is that we design an object, so at runtime this object will hold at least one pointer to dynamically allocated memory. Okay, so we just have to design, and I'm just thinking it could be a a block of things, basically memory block that contains things that are allocated dynamically. This memory did not exist when program has started. We use the new operator to allocate things at runtime and claim this memory from the operating system. So very quickly we discover, I think early on we discovered that, of course, making a shallow copy of this object is probably not a good idea. Basically, we don't want this pointer also point to the same block of memory. What we do is that we create a copy constructor that takes care of deep copy like this. So this dynamic memory is duplicated by our copy constructor, and this begins to point to its own memory. So now these two objects that manage memory dynamically become independent. This is a true copy. So we copy the object, but we also copy the dynamic memory, and we update pointers that point to dynamic memory. Essentially, also a clear signal for the need of copy constructor is that when you start using pointers, sometimes it may not be even related to using dynamic memory, but just using pointers to something may require the need to create a copy constructor. So then this slide here suggests that once you discover that you just added copy constructor to your class, it should signal you that you also need to consider adding an assignment operator. And we also can say, it doesn't mention on this slide because this slide was put together before move constructor became part of standard C++. But this should also signal the need for move constructor. Okay, we're just also we've had this example of a move constructor and tested it in our string concept. And of course there are two assignments, this deep copy assignment and also move assignment. So essentially just like I from practice, you probably discover the need for copy constructor first, because it just becomes such an obvious need very early on in your design. But just remember that you also need to consider copy constructor and also consider move assignment and deep copy assignment as well.